Hi, this is Mr. Lee. Here is our next video involving search and indices, and here we focus more on solving of equations. There's two parts of the question today, and part A deals with solving 25 power of x plus half minus 5 times 5 power of x plus 2 equals to 5 power of x minus 25. Okay, so for questions like this, when you have to solve equations, and especially when the x appears as an exponent, usually it might be useful, right, to replace this exponent term by another variable called u. Okay, and usually after this substitution, right, you find that this will convert the equation into basically a polynomial equation, for instance, a quadratic or even a cubic. But either way, it's going to be more manageable than what you have over here. At the same time, how do you recognize that this trick works? You find that in this case, 25 is actually a square. It's related to 5 as 5 square. Okay, so these are just some telltale signs for you to recognize. Okay, because of that, we can actually first set up things this way. Okay, so rewrite the 25 as 5 squared. At the same time, right, like in the previous video, when you have power x and power 2, right, split them up using the indices property. Okay, and let's simplify a little bit to see what happens. Okay, notice over here, you can actually multiply the two exponents together, and this will give you power 2x, and then multiply by 2 times half. Okay, with that in mind, you can roughly guess that you should actually replace your 5 power of x by the u. Okay, and that is what we're going to do over here. And if you do that, you find that the equation actually becomes a quadratic. Okay, because 5 power of 2x is actually u square. Okay, and at the same time, this guy over here actually is equal to 5. Okay, the rest of the terms just replace it by u, and I think should be quite straightforward. But this actually allows you to obtain a quadratic equation, which is nicely factorizable. Okay, and with that, you actually end up with u 5 power of x equals to 1/5 or 25. So how do you solve for x from there? Well, the trick in this case is to express the solutions in terms of powers of 5. For instance, again, 25 is 5 squared. For instance, 1/5, this is actually 5 to the power of -1. So now if you just so-called compare the exponents, you end up with x equals to -1 or 2. Okay, that settles part A of the question. Part B over here involves an equation of surds. Okay, so here you need to solve this equation. 2 root y minus 2 equals to y minus 5. So one trick over here is of course to square both sides of the equation so that you can actually carry out the surd. Okay, so if you square things up, this is actually what you get. And of course, the right hand side is y minus 5 squared. Just do a simple expansion. You get your y squared minus 12y plus 25. With that, similarly, you end up with a nice quadratic equation, which again is nicely factorizable to this form. So after getting to this step, you find that all you have to do is to say y is 3 or y is 11. Okay, but of course if you stop here, you find that this is not enough, because usually as a good practice, you should actually sub the solutions back into the original equation to check whether any of the solutions are invalid or not. Sometimes there may be some scenarios for that, so do take note of this. Here, if you notice, if you sub in y equals to 3 into the equation, let's take a look. The left hand side actually becomes 2 square root 3 minus 2. Okay, if you sub in y equals to 3, you end up with the left hand side being of this form. Okay, and 2 times 1 also equals 2. But if you now look at subbing in 3 into the right hand side, you get 3 minus 5, and that's your -2. The point over here is that these two guys are not equal when y equals to 3. So here you need to reject the answer for y equals to 3. In other words, the only solution that we have over here is y equals to 11. Okay, so whenever you do with equations involving surds, in fact, later when you see absolute value functions, logs, okay, do make it a point or habit to check back to the original solution. Okay, hope you found our video useful, and we hope to see you in our next video.